Hello students. Today we'll be talking about Runge Kutta method. It is a single step method. This method doesn't require calculations of higher order derivatives and give greater accuracy. In this we calculate the function values at some selected points. This method is better than the predictor corrector method as it has less errors in it. This method agrees with the Taylor series solution up to h raised to the power r, where r differs from method to method and is called the order of the method. So, Runge Kutta method, popularly known as RK method, is of different orders: first order, second order, third order, and fourth order. So, when your r is equal to 1, we are talking about the first order RK method. If we have r is equal to 2, we are talking about the second order RK method, and so on. So consider the IVP dy by dx is equal to f of xy with the initial conditions y at x naught is equal to y naught. The first order RK method when r is equal to 1 is similar to what we have in the Euler's method that we have already done in the last lecture. So the approximation formula would be the same in this case. Here we have the first approximation formula, that is y1 is equal to y naught plus h times f of x naught y naught, and so on. We can calculate the other approximations as well. Now we'll consider the second order RK method in this lecture where r is equal to 2. It is also known as Hume's method. In order to reduce the error in the multi-step methods, we use this method. The multi-step methods we'll be talking in the further lectures. If we have errors in the RK method of order 2, then we can use the RK method of order 4. So the general formula to find the approximate value for RK method of order 2 is given by K1 is equal to h times f of xn comma yn. K2 is h times f of xn plus h comma yn plus k1. Then we can calculate the yn plus 1 approximation as yn plus half of k1 plus k2. Now, if we wish to find out the first approximation, then we put n is equal to 0 in the above formula and we can get k1 as h times f of x naught y naught, k2 as h times f of x naught plus h, comma y naught plus k1. And thus we got our first approximation y1, that is y at x1, as y naught plus half of k1 plus k2. If we wish to find out the second approximation, then we put n is equal to 1 in this above formula, the general formula, and we can calculate it by k1 is equal to h times f of x1 comma y1, k2 is h times f of x1 plus h comma y1 plus k1, and y2, that is y at x2, is calculated as y1 plus half of k1 plus k2. In the similar way, we can find out the third and the fourth approximation as well. So let us consider one question. Here we have a question: apply RK method of order 2 to find an approximate value of y when x is equal to 0.2. Given that dy by dx is equal to x plus y with the initial condition y at 0 is equal to 1. So what is given to us? Here we have x naught as 0, y naught as 1, f of xy is equal to x plus y. Note here, if h is not mentioned in the question, then you can choose h on your own. Here, as h is not given in the question, then I'll be taking h as 0.2 because I have to find out y at 0.2. So it's better that we take h to be 0.2 so that we have less number of steps. So here you will see that y at 0.2 we have to calculate, that is y at x1. What is my x1? That is x naught plus h. So 0 plus 0.2 will give me x1 as 0.2. So using the above formula that we have just seen there, k1 is equal to h times of f of x naught plus y naught. X naught is 0, y naught is 1. So I just have to put the values in the f of xy, that is x plus y. So I get here 0.2 multiplied by 0 plus 1, that is equal to 0.2. So that means my k1 is coming out to be 0.2. Next, k2 is h times f of x naught plus h, y naught plus k1. So that is equivalent to x naught plus h means 0 plus 0.2. Y naught plus k1 means 1 plus 0.2. K1 that you have just calculated above. You have to put that value in this. Now, we first have to find out what is our new x and y. So my new x and y is coming out to be 0.2 and 1.2. Now I have to calculate the function value at these 2 points. Now the function f of xy is x plus y. So calculate the function value at 0.2 comma 1.2. That would be 0.2 plus 1.2. Then multiplied by 0.2, we get k2 as 0.28. So my first approximation, that is y1, is equal to y0 plus half of k1 plus k2. So when I substitute all the above k1, k2, y0 values here, I'll getting my y at 0.2 as 1.24. So this is the answer. Now what if h is mentioned in the question? So I have taken the same question here, same fxy, same IVP conditions. Use RK method of order 2 to find the approximate value of y when x is equal to 0.2, given that IVP dy by dx is equal to x plus y at 0 is equal to 1, and h is 0.1. So as here h is mentioned to us, so what we have to do, we will be calculating the first approximation first, and then we move ahead to the second approximation. So let us see here. X naught is 0, y naught is 0, f of xy is x plus y, h is equal to 0.1. So what would be our first approximation? The first approximation would be y at x1. X1 is x naught plus h, that is 0.1. So I'll be calculating first the first approximation, that is y at 0.1, using the same RK method formula of order 2. So k1 would be h times f of x naught y naught, that is h times x naught plus y naught. So here I am getting k1 as 0.1. K2 would be h times f of x naught plus h, comma y naught plus k1. When I substitute the values, I am getting f of 0.1 and 1.1. So I'll add them, 0.1 plus 1.1, which is equal to 0.1 into 1.2. Here we know that f of xy is x plus y. So whenever you have any value of x and y and you substitute in your function, you just have to add them. That's why we are adding here the values 0.1 and 1.2. So ultimately I am getting my k2 as 0.12, and this is my first approximation, y1, that is y at 0.1 as 1.11, by putting all the values in the formula. Now, here we have to find out y at 0.2. So let us find out the next approximation, that is the second approximation at y at x2, where x2 is 0.2. So using the above formula of order 2, now we have k1, which is h times f of x1 y1. So please note here, when you are doing it for different approximations to find your answer, so your k1 would be different every time, and moreover your first of all it was f of x naught comma y naught, but when we are finding out this second approximation, so we'll be using the previous data points, that is x1 y1, to find the second approximation. So as RK method is a single step method, so here you would see that h is 0.1, f of x1 comma y1 is x1 plus y1, x1 is 0.1, y1 is 1.11 as we have calculated above. Put the values and we find our k1 as 0.121. K2 is h times f of x1 plus h, y1 plus k1. Now which k1 we are talking about? The k1 that we have just found out above, that is 0.121. Putting all the values here and substituting in this, again f of xy is x plus y. So when you will calculate f of 0.2, so your x is 0. So now k2 would be h times f of x1 plus h, comma y1 plus k1. So x1 plus h is 0.1 plus 0.1. y1 plus k1 would be y1 that we have calculated above, 1.11, plus 0.121 k1 that we have just found out above. Then putting all the values here, we will calculate k2 as 0.1431. Now y2 would be y1 plus half of k1 plus k2. So substitute all the values here and we are getting our y2, that is y at 0.2 as 1.24205, which is approximately 1.24. It is the same value that we got when we have taken our h to be 0.2. So that means whether you take your h to be 0.2 or you take your h to be 0.1 and you calculate two approximations, the answer would be approximately same. So this is the end of the RK method of order 2, and in the next lecture we'll be talking about the RK method of order 4. Thank you.